2.3a, multiplying integer fractions. When we multiply fractions, we multiply straight across. Oops. This means we multiply numerator with numerator and denominator with denominator. So for example, 2/3 times 1/2, we would multiply the 2 and the 1 and the 3 and the 2. So 2 times 1 is 2, and 3 times 2 is 6. So the answer would be 2/6, which can be reduced to 1/3. Remember to keep track of signs. Remember that a negative times a positive always ends up negative, but two negative signs ends up positive, right? If there are negatives on top and bottom of a fraction, that's the same as having two negatives and the whole fraction is actually positive. So let's go through some examples. Compute 6/7 times -4/10. So we multiply straight across. So 6 times -4 is -24, and 7 times 10 is 70. So we could leave it like this, but usually we want to reduce a fraction down to its most reduced form. So I'm going to divide top and bottom by 2, because I notice that they're both even, right? And this is a -12/35 now. And I think that's as far as I can go reducing. So the answer is -12/35. So let's move to a second example. If a diagram of an engine has a scaling factor of 3/8 and the stroke length of the engine is 4 inches, what is the stroke length of the engine in the diagram? So we kind of have to decompose this sentence real quick. What does scaling mean? So scaling means multiplying by this number. So we're multiplying the size of the engine by 3/8. So it is 3/8 the size of the real engine. So the stroke length of the real engine is 4 inches. So that means to find the stroke length of the diagram, we have to multiply 4 inches times 3/8. So when we have whole numbers are actually fractions with a denominator of 1. So if we look at this 4, the first thing we have to do is turn the 4 into 4/1. Because 4 divided by 1 is just 4. So this is an equivalent way of expressing 4. It's just we need it in fraction form to multiply fractions. So carrying out this operation, 4/1 times 3/8 is equal to 4 times 3 is 12 on top, and 8 times 1 is 8 on the bottom. Now we can reduce this by dividing both top and bottom by 4, right? I notice that they're both divisible by 4, and I end up with 3/2. So my answer is 3/2 inches. So that would be the stroke length of the diagram engine.